This video is going to focus on proofs regarding corresponding parts of congruent triangles. The strategy for this is that you'll want to write the three congruent parts and then state that the triangles are congruent. So you would have your congruent statement. After that, once you've established that the triangles are congruent, then you would just simply write the proof statement. And the reason that you would use for it is this: corresponding parts of congruent triangles are congruent. The basic idea is simply this: you're still going to prove that two triangles are congruent to one another, but then what it is that you'll be asked to determine some other parts of the triangle are congruent, and you unfortunately won't be able to do that as a normal course of the problem. So what you do is you just prove the whole thing is congruent, and then you go and you backtrack. Let's take this example here. You're given two pieces of information. You have two right angles, and you have that W is a midpoint of segment OY. So prove that these two angles are congruent. What we're going to do is we're going to prove that the triangles are in fact congruent to one another before we even get to angle B and angle T. Remember, this is the strategy. First write in your congruent parts, then the triangle statement, and then the proof statement, which is angle B congruent to angle T. So let's go ahead and put in what we already know. We already know the given stuff. We also know how it ends, though. So we have angle B congruent to angle T, and plus the triangle statement we know goes right before it. In addition, we also know the reason for this, and that's this: corresponding parts of congruent triangles are congruent. So what we need to do now is, just like before, identify our three congruent parts, and then we can finish this off. So what do we know? Well, you know that angle O is congruent to angle Y. Those are right angles. And right angles, you may recall, are both 90 degrees. So let's go ahead and write that in. Angle O is congruent to angle Y. You'll note that it comes right after this statement. You don't want to put it here, though technically there's nothing wrong with it. The reason why I'm putting it right after this is because we needed to know that these were right angles before we can state that they were equal. So that's the reason. Right angles are congruent. You can put definition of right angles. That'll work as well. Basically anything that states that you know that they're right angles and that because of that they're the same. Okay, W is a midpoint of OY. That tells us something. Since it's regarding a segment here, what we know then is that OY, that's this one, has a point in the middle which essentially cuts this in half. So we got two equal halves. And that is something you can always look for. Whenever you're given a midpoint, and the midpoint is for a side, for a segment, just cut that segment in half and you get two congruent parts. So let's go ahead and put that in, and that of course follows the midpoint statement. And your reason for that is just by definition. That's what a midpoint does. It creates two equal parts. Okay. Hopefully by now you've spotted the third part, and that is angles 1 and 2. Do you remember what kind of angles they're called? You guessed right if you said vertical angles. So vertical angles are congruent to one another. So let's see what we've got here. We have OW and WY. We have the two right angles, and of course the vertical angles here in the middle. So that's angle, side, angle. So that goes there for the triangle statement, and that really finishes it off. Except we know that the last part isn't just to show that the triangles are congruent. We need to know that angle B is congruent to angle T, and the reason for that is corresponding parts are congruent. Meaning this: since we know the triangle here is congruent to this triangle, then that means that we also know that this angle equals this angle. We also know that this side equals this side, and we also know that this side is equal to this side. In other words, all the corresponding parts are going to match with one another. Because of that, we could have gone further. We could have stated that OB is congruent to TY. Reason: corresponding parts of congruent triangles are congruent. So you can do that all day after you've proven this part here. Alright, here's another. In this particular case, you are given a pair of sides being congruent, and you're given a pair of angles. So prove that angle A is congruent to angle E. What is tricky about this is that you're given side CA. This is this entire length, which means we're probably not just talking about this particular triangle here and this particular triangle, because CA is a lot longer than any of these any sides that are given for these two particular triangles. Remember that these are our steps. Let's first put in what we already know. We again know these two parts, they are given. We know we need to write a triangle statement, and then we need to finish off with angle A being congruent to angle E. As far as the triangle statement, I left that blank because it's not so clear-cut here. We do have this triangle and this triangle, but hopefully you've also spotted two more triangles. You have a triangle here, and you have another one that overlaps, namely here. Because we're talking about side CA, we're probably going to have to refer to this bigger triangle up top. Why don't we redraw this? If you're just looking at this particular triangle here, and you notice that I've marked CE, I'm going to drag that down. Then when you look at the other triangle, I'll have CA marked as well. Plus, you'll notice that I have the numbers for the angles and then the sides. You'll note that there is no letter F in either of these two, so we're not going to be referring to any kind of angle F here. So look at what you've got. We have angle 1, angle 2. We have a side here. What's the third part? Well, going back, you'll notice that they both have an angle C. See that? In fact, no other letters repeat. Because they both share the angle C, we would say then that angle C is equal to itself. Now, whenever you write that, the reason for that would be reflexive. So this is one that is not so obvious because of the fact that the triangles overlap with one another. Okay, let's clean this up a little bit. What I'm going to do here is, because we only have so much screen, I'm going to take this triangle here and just remove it, because I only really need to focus on just one of these two. Alright, that's better. So for the triangle statement, well, we had triangle A and ACD, right? So that's going to be congruent to ECB. Remember, we're linking together the equal angles. You know that angle A is going to be equal to angle E because we're going to have to prove that in the end. So A goes first, E goes first. C equals itself because we established that here. That leaves D and B. So what's the reason for it? Well, if you're looking at this here, side, here's an angle, here's another angle. The side is not between the two angles here. So angle, angle, side. And last but not least, remember the reason that we use? There it is. A word of note, some textbooks will have, in fact some professors will also allow for you to write, corresponding parts of congruent triangles are congruent. Put these initials CPCTC. That's not really something that I encourage because a lot of students will tend to rewrite this wrong. I mean, it'll morph from this to CPT, PC to, next thing you know, it's this, C, me, PP. So a lot of people will eventually begin to morph these letters, and next thing you know, they forgot what it means. In fact, a lot of times you'll simply ask, well, what does it mean? CPCTC. I don't know. So instead, I encourage you to write this out, and yes, it's a long statement, but it's not like it's an essay. That's it for this one. I'll see you next time.